Hello everyone, this is going to be a quick recap video, well maybe not quick, but it's going to be a recap video of what we did in class today, or what you should have done in class today, looking at the slopes and functions from your position versus time graphs in class. So first, let me just point out that I did not include the variables here because I wanted to bring some attention to them, right? So the physical quantities that we measured today were position, which we give the symbol x, alright, and time, which we give the symbol t. These are our two variables that we're using, so when we mark this off on the graph, we will call this x, position, right, and this was in centimeters, and this was t, time, measured in seconds. Now, in class I asked you to find the slopes of your graph, correct? And most of you came up with the idea that the slope obviously has something to do with the speed of your graph, correct? Or the speed of the car represented by the graph. Since you know that this has a bigger slope and this was the faster car, so perhaps the speed was given by this slope. It turns out that you are almost correct, but not quite, because this is not the speed, it is something we call the velocity. Alright, velocity, which we give the symbol v. The velocity is defined as what we call the change in position over the change in time. Now if you notice, if you find the slope of this graph, what you are doing is you're finding the final position, right? To find the slope you find y2 minus y1 over x2 minus x1, but in this case we don't have y and x, we have position and time. So if we find if we find y2, or in this case position 2, which we'll take for the red one as 100, let's write this in red. So v for the fast car is going to be x2, or position 2 for the fast car, minus position 1 over t2 minus t1. Alright? Now, instead of writing 1 and 2 like we're used to, I'm going to change this and make it initial and final. X final minus x initial over t final minus t initial. Alright? Now in physics, this right here is known as a change in something. If you do the final minus initial, the change, in this case it's position final minus position initial, so it's the change in position. So this, we'll rewrite this here now, or well, let's rewrite it down here. So v for the fast car is equal to the change in position of the car over the change in time. It is at this point that I would like to note that the little triangle that I drew there is actually what is known as a delta symbol. In physics we use that to signify a change. So anytime I put a change in anything, there's always going to be the little triangle in front of it, meaning change. So that's change in position, delta x, over change in time, delta t. Same thing here, right? T final minus t initial, so this is the change in time. Now, for a car moving with a constant velocity, alright, it is simply, like we just found out, the slope of the position versus time graph. Right? And this is equal to the change in position of the object divided by the time interval during which that change happened, or the change in time. And so when the object is moving at a constant speed like these cars are, then that ratio of change in position over change in time is the same for any time interval. No matter how long you time, that change in distance is going to be the same. That's why you got those pretty dot diagrams, right? And so if you look at the units for this, if the position unit in this case is centimeters and the time unit is seconds, what you've got here is the units centimeters over seconds, right? So yes, so this in fact does mean that the slope of the line gives you the velocity. Okay, and I'm using velocity for a very specific reason that I will explain in a little bit. Now, the reason we use velocity is the following. If you look, I've got here a number line, alright, which tells you the measurements. Now, in class, you all measured from 0 and went in a positive direction. Alright, this was the positive direction, this is the negative direction. And I asked you, what do you think it would mean if your slope was in fact negative instead of positive? Well, let's draw a line with a negative slope, and maybe we can figure out what that means. So, if this is a position versus time graph, what this tells us, first of all, the y-intercept here tells us our initial position. If we go back, we see that our initial position was always 0. Alright? So if we go back, our initial position here is 4, so we started off at 4 meters at time 0, whatever it was, let's say a ball, right? And then every second, at 1 second, we end up at 3 meters, at 2 seconds we end up at 2 meters, at 1 second we end up at 1 meter, and so on and so forth. So the dot diagram for this would probably look something like this. What we see now is that if we found the slope of this line, you can sort of tell, right, the slope here is -1, okay, for every one it goes down 1. What this means is that our velocity is now -1, in this case, meters per second. This just means that it's moving in the negative direction, okay? Negative here means that moving in negative direction. That is what the negative means. And that's why I call this velocity and not speed. Okay? Velocity and speed are two different things. Velocity is the rate, like we said, delta x over delta t, right? The rate of change of position in a given direction. Okay? In a given direction. Whereas speed is simply essentially the absolute value of velocity, or just how fast it's going. So it's just the rate of change of position. And yes, I realize that this says change here, insert an H. My bad. Okay, so that's the difference between velocity and speed. So the equation we found before, the delta x over delta t, that is velocity. Okay? If you find the absolute value of delta x, it is the speed. Now, let's take a step back for a second and look at one more thing. So the last thing I asked you to do in class today was to find a function for these two graphs, right? So whenever physicists want to represent a pattern between two variables, we use a function, all right? A function is a rule that we use to find a dependent variable when an independent variable is known. In this case, the independent variable t, right, affects the dependent variable position. So the longer t goes on, the farther the position is going to go. So in math, when you learned functions, it was usually f of x, right, or y of x, where it was the function as it relates to x, or it was the y, right, the y value as a function of x. In this case, we're not looking at just a function or y, we're looking at the position x as a function of time, t, okay? And so if you remember your line equation, right, this equation here, the equation for this line is going to be similar because it is still a line, right? So we can sort of base this off of y equals mx plus b. So what are the different aspects of this as they correspond here? Well, let's start with b. B is simply the y-intercept, right? In this case, though, the y-intercept is not just the y-intercept, it's where our car started. From our equation here, it is x initial. So we'll start off with plus x initial as b, right? We're trying to find the function here, the equation for this line. Now, we already know that the slope is velocity, okay? The slope of a position versus time graph is velocity. So we're going to put this in here, v. And finally, we have our x variable. Okay, this we're not going to fill in any numbers for this when we write this out. This is just going to be our x variable. In this case, our x variable, or the independent variable, is going to be t, time. So now we have our function, position as a function of time. All right, let's do one more quick example, and then we're out of here. So let's take a look at this problem here. So we've got a table and a few questions. Describe the relationship between the two variables, describe the variables used in the scenario, and write a mathematical equation using these variables. So first of all, let's take a look at this relationship in this table. In this table, we see that for every second that goes on, whatever this thing is doing moves 50 meters in every second, okay? 50 meters per second, which must mean that our velocity in this case is positive 50 meters per second, right? So that's the relationship that we have. Describe the variables used in the scenario. The variables in this case are position, right, x, and time, t. So if we were to write a mathematical equation using these variables, we would get right? Our function, x of t, x position as a function of time, is equal to velocity, right, times time plus x initial. Well, our velocity we know is 50 meters per second times t. We don't have to fill in t because that's our independent variable. And our x initial, if you work this backward at time 0, we should get 0 meters. 0. So all we end up with is the equation equals 50 meters per second t. All right. Now, if this were moving in the negative direction, and let's say instead we had, I don't know, let's say we had 150, 150, then we would end up with actually a negative 50 meters per second times time, right? Because every second that goes down, it goes down 50 instead of up 50, so that would be a negative. We'll do more problems like this later. You will have a quiz tomorrow. And you'll notice that I didn't ask you to answer any questions in this video, so how do I know you watched the video? Well, if you, on your quiz, somewhere in your quiz, I don't care where, it can be in the middle of a sentence out of nowhere, it can be right at the top, write the word velociraptor. Okay? That is how I will know that you watched this video. Get it? Velocity, velociraptor. So, if you write this word somewhere in your quiz, I will know that you watched this video. Alright, thanks for playing. See you later. Bye.